So in your previous classes, you have seen basics of JavaScript. You have seen what a function is, how you can create a function in different forms, how you can associate or how you can do any type of calculations when you are writing your functions in JavaScript, how you can modularize your JavaScript class, your JavaScript to have more and more features put at proper places, and so that you can call them again and again. So due to all these things, bring in the usage of something called, or bring in your functions into picture. When we are writing function, there are multiple ways of writing your functions, as in which you have seen also. All right, so when you write your functions, whenever you are writing a function, can you tell me what are different ways of writing a function or defining a function? How exactly do you write a function? Nilima, when you define a function in JavaScript, how do you do that? What are different ways of defining a function? Okay, yeah, correct. So we say, let's say this is one way. We say function A, and then these braces, and we say that this is a function. When we are saying this, there is a specific term used for when we are creating a function like this. Do you know what that term is called? Anyone? Okay, let me ask you again. Do you know any other way of defining a function in JavaScript? Correct, Mala. So is there any other way that you know using which you define a function? Absolutely correct, Mala. So in JavaScript, we can define functions in two ways. One is your function declarations, which are precisely using your function keyword, and then you can have them parameterized or pass any arguments to them as you desire. And then another is by using your function expression. So whatever function you are writing, you simply create a variable. So yes, absolutely correct. You define it saying something like this. Now, this is called your function declaration, or let's say named function declaration, and this is called your function expression. All right, so we have two ways of defining our function. Now, whenever we are writing, today we are going to discuss about various JavaScript patterns. So what exactly a pattern is going to be? Any language that we have, it opts to few standard as in the terms of how you are going to create or how you are going to design your application. So similar thing goes for your JavaScript as well. When JavaScript was designed, it was in very much of a need that you cannot always just keep on writing things. You cannot just always keep on creating objects or keep on creating functions altogether in JavaScript. You need something that will design or that will lay out the structure of your application, that will lay out the structure of the way you are writing your code in JavaScript. So your design pattern in JavaScript simply, or in any of the language, are simply the common design standards or common design structure that make it very useful for you to create an object oriented design, a design on which that language is, on which any language is built up of it. They allow you to create your designing or structuring of your applications using a particular language very easily, and they provide a layout for you, a layout in the manner that how exactly you should follow a particular pattern in order for you to create your applications more easily, more providing them more enhanceability, providing them more reusability. All those things can be done by using your design patterns. So now the very first design pattern that we are going to talk about is called your IFI. IFI stands for your immediately invoked function expression. This is one of the very basic design pattern, or this is one of the very basic pattern that JavaScript uses in order to create, or in order to create functions and then simultaneously create constructor, simultaneously create objects and so on. Now this pattern is not explicitly designed or explicitly termed as a design pattern, but this pattern is going to be used by various other patterns in order to define or in order to construct your applications in a way better manner as compared to when you are just writing your function straightforward. So first of all, let's say how we define a function. There are two ways. One is by your function declaration, another is by your function expression. Whenever we are writing a function expression, anything that is being created around the context of an expression is a function expression. For example, let's say this is one expression. Whether I pass parameter to it or whether I create some nested function inside it, that's up to me how I want to create it. But if I do something like this, let's say if I'm creating something like this, function okay, so if I'm creating something like this, where I have just put a function inside a body itself, where I'm surrounding this function within the braces, round brackets, that also itself is a function, or that's also an expression. So even if I'm saying this or if I'm saying this, that's also your function expression. Function declaration is something where you make use of my function keyword and you put things together. So now whenever I want to, okay, so when I'm creating a function expression, the ideal thing about your function expression is that they return you something. They return some value. That value can be any calculations that you are doing inside, or any expression that you want to put inside, any statement that you want to put inside. So the general ideology behind writing your function expression is that they are expected to return you something which you can make use of, or print, or do any sort of calculation. So when this type of expressions are needed, either you access them by calling the function name, or you access them by objects, or by any objects that you are creating, there arises a need that is there any way for us to create or to invoke these expressions right away, which means that you do not have to create any object, you just want to access these functions right away. So for that, what do you need to do? Just provide this square round bracket after that, which means, let's say if I have to call that function normally, what I would do, I will simply create an object of it. Let's say whatever function I'm defining, let's say over here I'm setting up some property. Over here, let's say I'm printing console.log. Now if I have to call that function, all I can do is just use x dot whatever, just call this x method and then make use of it, create an object and simultaneously call that function, right? But what your IFE says, that rather than you to make use of creation of an object in order to create, in order to call the function that you have created, all you have to do, if you see, if I have to call this function, I would be doing something like this. But what your IFE says, rather than you providing a namespace to the functions which you are trying to call, just invoke it like this. After this expression, just provide this square bracket, provide a round bracket, so that this function, the expression that you have written can be invoked immediately. You do not have to do something like this. So this type of expression, this type of calling of a function is called your IFE. Why? Because these methods, you are not creating any namespaces, you are not creating any named function. All you are doing is writing a method, and after the end of that method, you are immediately calling that method. You do not have to create an object, you do not have to create a variable in order to call that function. Obviously the similar thing can be done by writing a name of the function and calling it and so on. But what it says, that rather than providing names, if you have a need to get a function invoked as soon as it is being written, you do not want to create multiple objects, you do not want to write multiple expressions for it, you do not want to write anything else, but you want a function to be invoked at the same place where it is being written, you can follow this pattern which is called your IFE. And what that pattern says, that whenever you are writing a function expression, instead of providing it a name, instead of creating a namespace for it, just call it at the same place and do the calculations within. So why we are doing this? First of all, we are avoiding creating multiple namespaces in the sense we are not providing a name, we are avoiding the let's say tomorrow if someone else wants to create a function with the same name, there can be a conflict in the naming convention in the namespace that we have provided. And this function, when we have defined something like this, it is self-documenting as in we know that when we are using our IFE, when we are using this particular pattern, we are making sure that that method is being invoked, that function is being invoked by itself. We do not have to do anything else. As soon as our compiler will be encountering this type of statement, the code within itself or whatever calculation we are going to put inside are going to get invoked, resulting into what we want to do. So let's say if I create a project now, let's see the implementation. Let me create an HTML as well. All right. Now, let's say if I have to write a function which should be invoked with itself, but what exactly should I do? I will be writing a function expression, but function expression in the manner that I need to invoke it by itself. I do not have to do anything else. So now, once I'm doing this, let's say over here, I'm printing an alert. I'm showing an alert. Then if this is just an expression I have written, tomorrow if I have to invoke it, obviously I have to find a way, I have to create an object or I have to do any type of calculation within. But if I'm using IFE, what I have to do is just invoke it at the right place. Why? Because this is just an alternative how you are going to write an expression. If I would have said this, I would have called it saying something like this, right? This is how I'm going to call that function whichever I have provided. So if I'm doing this, I'm creating a namespace, I'm calling this function. But what if he says that all you are doing in order to call a function is just providing this square round bracket? Then why can't you do that within your expression? You have an option of doing the similar thing by just providing your round brackets at the end of function, so that this function can be invoked by itself. And this pattern, this approach of writing your functions is called your IFI. Why JavaScript move towards this IFI pattern? Why? Because it allows you to obtain data privacy, as in that whatever variables, whatever calculations you are going to do inside this function, as you know, there is a scope attached to every variable that you create. Your variables can be globally scoped and they can be locally scoped. So whenever I'm creating something like this, I know that the variables that I'm going to put inside, they will not be accessible outside. Any calculation that I'm going to do, that has to be done within the function itself. So this pattern again is called your IFI pattern, which means calling or invoking the function with themselves without the need of creating the namespaces, so that you can avoid any conflicts in terms of your method, in terms of your function names, in terms of your execution. You just have to invoke them at the same place. Now if required, this is one simple example of your IFI. If required, you can obviously pass parameters to your IFI as well. How? Let's say if I create any variable, I can pass it over here saying MSD, or whatever variable name you want to give it, and let's print it. And see how it is going to execute. So let me run it to show it to you first. Oh, sorry. So if you see, hi is being printed over there. To pass a parameter, what I did, this is the parameter that I need to pass. This is a variable that I need to pass. So if I have to pass something within this method, within the function which I have written, normally I would be passing it over here, right? I will be doing something less like this. But if we are saying that this is how we invoke a method, we want it, we invoke a function, we want it to be invoked by itself. So whatever parameter I have to pass, just like how you pass it in a normal function invocation, we are passing that over here. This parameter is now being collected by my function, which is by x, and then finally we are printing it. So it's similar to whatever you are going to do by writing a normal function expression. If he says the way you are expressing, the way you are writing your function expression, just alter it in some way that you do not have to create a namespace for it. All you have to do is just provide the body, the round brackets alongside your method call, and that's it. Whatever parameters you have to pass, you can pass it from there as well, rather than creating your global accessible properties, or rather than creating your namespaces. You can invoke your functions by just providing this type of implementation, calling a function by itself, calling a function by at the point of its declaration, at the point of writing a function itself, is called following your IFI, or writing your function by following your IFI, which means invoking your functions right at the point where they are being written. Clear? So this is what your IFI is all about. Is this clear? Patterns are very important for you to understand, so please ask me anytime if you're not understanding any of the patterns at any given point of time. So is this, I'm going to ask it again, is this clear? All right, so now next pattern that we have is one of the most used pattern, which is called your constructor pattern. Okay. As we all know, JavaScript is an object-oriented programming language, as in it follows most of the concepts of your any of the object-oriented programming language. It follows your OOPS concept, but among those OOPS concepts, we know that one of the few basic things that any object-oriented programming language follows is the phenomena of creating classes. But in JavaScript we do not have classes. We just, everything in JavaScript is an object, right? Whatever you write, whether it's a function, whether it's a variable, whether it's a any array or anything at all, everything inside your JavaScript is just considered to be an object. JavaScript does not follow the ideology of creating the classes. Then what exactly is going to be a constructor? What exactly, if we are not creating a class, or if we are not defining anything in JavaScript in the format of a class, what exactly is going to be a constructor? For your JavaScript, constructors are more of your object constructors. What exactly is a constructor? Let's say whenever you are creating an object, you want that object to set some properties, to call some methods, to instantiate some values associated with them. Whenever you are creating an object, you want something to get started with it. For example, let's say if I have an object, I am creating an object of car. What properties this car can have? Car can have color, car can have model, stuff like that. So all these are the property of my car object. Whenever I want to set these properties, I want these properties to be set according to various instances of this car. For example, let's say if I am creating a creating an instance of Hyundai, it has a different color, it has a different model. Similar thing goes for your Toyota or any of the car models that we have. Let's say BMW. All these are my car models, and based upon that, I want to set some properties, I want to define some properties along with it. So constructor is one of the most used and one of the most prominent way of setting these properties when it comes to creating your objects. Whenever you are creating an object, you want some values to be defined with it, you want some values to be set as soon as you are creating an object. So to do that, what exactly you can do? Okay, can you please before that tell me how exactly do you create an object in JavaScript? When I'm saying that you need to create an object, how do you create an object? In JavaScript, do you guys know how do you create a object? Okay. Yes, absolutely correct. Whenever you are declaring anything, whenever you are creating any variable, you are precisely creating an object of it. That's everything that you are accessing, whatever you are writing, that is considered to be your object. For example, let's say if I want to create, let's say if I want to just create an empty object, what I can say, either this, or I can say I'll tell you what exactly I'm doing. Okay, so now whenever I want to create an object, there are three ways. Either I say I create an empty project saying something like this, or there is a prototype inside my JavaScript for various things. For example, let's say whenever you are creating a string, whenever you are creating a number, all these things can be created by, there are 8 different prototype classes or syntaxes that JavaScript provides. That those 8 are for those 8 things are, for example, there is a class called, or there is a reference object called object, there is something called string, there is something called number, there is something called regular expression. All these 8 things, they are a part of your JavaScript, and they are used to define your objects in the manner that you want. For example, let's say, let me explain it in a better way. For example, let me first tell you. Can you guys tell me what is an object? Let's first start from there. What is an object? Okay, it's a variable, it's an instance of a class. Okay, fine. What exactly an object is going to contain? Okay, it contains more than one information. Method and properties, key and values. Yes, absolutely correct. So whenever I'm saying an object is going to contain more than one values, which means it will have some keys associated with it, it will have some values associated with it, it can have some methods, it can have some properties. Anything that defines, that identifies that object, that represents that object, that becomes a part of my object. So now let's say whenever I have to create an object, by default we know that JavaScript offers, or anything that I'm creating, whenever I'm creating a variable, I can create a variable in 2 ways. Do you guys know, whenever you are creating a variable, whatever type of, whenever you are saying var or something like this, what exactly is happening in the backend? Do you guys know? let's say whenever I say var x is equals to 5, what exactly happens in JavaScript? It is allocating some memory space. It is defining a numeric value for me. Now, in JavaScript, by default, there are 8 constructors involved. What those constructors will be doing, those constructors set up these values for it. So whenever we are allocating, whenever we are saying var x is equals to 5, for us, we are just creating a variable. Or let's say whenever we say string, let's say name is equals to, whenever we are creating any variable, for us we are just defining a variable which should have this type of value associated to it. That's it, done. But in your memory, in backend JavaScript by default has 8 constructors based upon the type of variables that you are creating. Those constructors will be the place that are allocating the memory space, that are actually setting up the values for you for your variables. What those 8 constructors are: we have something called object, we have string, we have boolean, we have number, we have date. And as everything in JavaScript is coming from object and you need to set those values as well, your function, whenever you see this function thing which you will be using a lot, this is also a constructor provided to set the values of the functions that you are writing. Whatever you do corresponding to all the things that you are doing, that is being set by this function constructor. And then we have something called regular expression. So in total, in the backend processing of my JavaScript, there are 8 constructors involved who are going to set the values of the variables that you are creating. Whenever we are creating a variable, we generally create them by doing something like this, by saying something like this. This type of creation of variables is called creating a variable by literals. This is called creating a value by using your object literals. The definition, the declaration of your variables when you do something like this is called creation of the variables by using your object literals. But there is another way. If you do not want to do this, you can create these variables by using their corresponding constructors. Constructors, as I told you, are again a place which will allow you to set the values of an object, which will allow you to actually start those variables, actually allocate memories to those variables and set up the values that you are passing to those variables when you are creating them. So for example, if I have to create a variable by using the constructor of it, what I can do, I can simply say var x is equals to, let's say, new object new number and pass value to it. So this expression and this expression, they are going to do the same thing. Now this JavaScript makes it easy for us to write or to declare our objects, to declare our variables. So what it says, that just create your object literals and provide values to them the way you want. But in the backend, in the processing of this variable, whenever the memory space is being allocated to this variable, this is how JavaScript is going to convert it into. It is going to create, it is going to call a constructor. Now number is a constructor of your of an internal constructor of your JavaScript. So whenever you are defining this, JavaScript will be doing this. JavaScript is going to create an object by using my new keyword. New keyword is used to create explicitly the objects of in your JavaScript. So whenever I'm saying new, I am telling that I need to invoke this constructor by passing a value which is 5, which will precisely just create a variable having a value 5. So whenever we are used to creating our variables by using our object literals, why? Simply because they are easy to create. But if you want, you can create your variables by using the constructors that are provided by JavaScript. Internally, whenever you do this, JavaScript is calling a constructor by passing this value so that it can set the values corresponding to the property which is named. So right now, what is happening? There is a string object being created with a property name whose value is being assigned as Mala. So this is how internally JavaScript processes every value, that every variable that you create, whatever value you want to associate with it, that value is going to associated to it by creation of an object. That object gets instantiated, that object gets assigned value by the usage of the constructors that we provide. So internally, every value allocation is being done by the constructor, and that's what your JavaScript is doing. So now, to make it easy, we know that by default we are providing a constructor are something which will be used to create objects or to set up values for it. So how exactly you can make use of this constructor pattern to create your user defined objects, to create objects and set some values to them? How exactly can you do that? That we will see up next. So is this clear? Till now, is this clear? Are we clear about object literal notation and then create a usage of constructor inside your JavaScript? Is this clear? All right. Now, let's say if I have to follow this type of pattern in which I will be setting up my object value by using constructor or by following the constructor pattern, how exactly am I going to do that? Let's say, as everything in JavaScript is either an object or a simple function that you are writing, functions which are again objects. So what we are going to do, let's say if I write a function book, then over here I'm creating an object B, then I'm creating an object by using this notation. This is now not an object literal. What I'm saying that you need to create an object by using a new keyword. New keyword is used to create objects of any of the functions or any of the methods within your JavaScript. New keyword allows you to explicitly create objects which can have some properties or some methods within itself. So now, whenever I'm doing this, what I'm trying to do, I am this now constructors in JavaScript are also just like normal function. What is the difference? That with a normal function, you started with a small letter, but to differentiate between writing a normal function and the constructor, what JavaScript says that keep it as a keep your first alphabet of your constructor declaration as capital, indicating that now it is going to be a constructor which will set some properties, which will define some instances, which will create an instance of the class that you have provided. So what we are saying, we are just creating a function which we are creating as book, and then when we are creating an object of that, we are saying new, and then we are calling or we are creating an object of that by calling this constructor. This constructor would be the place where we want to set some properties along with the book object that we have created. Now, to make it more simpler, let's say if I print, do you guys know about instance of operator? Do you guys know what instance of is? Okay, instance of is an operator in your JavaScript. Sorry, it's basically, it's a keyword in your JavaScript that allows you to check whether the object that you are creating belongs to a particular what do you call it, belongs to a particular simply putting, okay, whenever we are creating an object, what your instance operator is going to allow you to check, it will allow you to find whether an object is an instance of another one or not. So for example, this is one object. This object, I am referring it by this variable. So what your instance operator is going to find out for you, it will find whether this object that you have created, whether it is an instance of another object or not. So just to make sure that this variable that we have just created, this object that we are, which is referring to this object, whether it is an instance of this book object or not, we are just making use of instance of operator. Now let's see what it prints. If I'm refreshing, it prints true, which means this reference variable, this object that we have created, it refers to an object which is of my type book. Now let's say if I do something like this, what do you think, what should be the result of it? Can you tell me now whether this will give you true or false? Anyone? We have internally, we have these are also my constructors. Whenever I'm creating an object, I say new string or something. Let's say if I have to create a string, I can either create by this object literal, or I can say new string mala, this type of notation by using the constructor. So just to check whether the object that I have created is an instance of some other object, we make use of instance of operator. We are saying v is equals to new book, which means we are creating an object by calling the constructor of this object. So now when I'm doing this b instance of string, what do you think? Is this b instance of string constructor? Yes, absolutely correct. This will be giving you false. Can you tell me why it will give me false? Can you tell me why it will give you false? Even if I comment this over here, so this is a constructor for my book. I'm creating an object by calling this constructor, which should set some values corresponding to the object that I have created. So whatever code I want, I can put over here. When I'm checking whether B is an instance of a book, that gives true. But when I say B is an instance of string, it gives me false. Why? Take a guess. Speak your mind. What do you think? Why it is false? No, even if I move it first, even if I say it yes, so if I'm just placing them, if I'm just changing their order, how does that going to impact? So let's say if I'm keeping it on the first row, it's still giving me false. So it does not matter. Okay. Every time you are creating an object, no, it's not an object of string. Every time you are creating an object, it belongs to a specific object within your JavaScript. Those objects get instantiated by their corresponding constructor, which means, let's say, whenever I'm creating a string literal, whenever I'm doing var name is equals to Mala, internally it's calling an constructor, which is a constructor which is called new string, and passing this variable which sets this variable's values to Mala. So this name variable is obviously an object of this string. So this name is an instance of this string object. So which means instance of operator tells you that the variable, the objects that you are creating, whether it belongs to another specific objects or not. So based upon the type of object you are creating, these variables will be belonging to those particular objects only. So for example, when I create an object like this, and if I say if name is an instance of string, yes, true. Why? Because it is going to be created by invoking this type of constructor. Over here, we are creating our own constructor. We are creating this type of function. And when we are creating an object, we are invoking this function. We are saying new book. So to start any object, we make use of a new keyword. We say new, and then we call the constructor to set some values. These values which are being returned by this function, which is precisely a constructor now, are being collected into this variable. Now to check whether this variable that we have created is actually an instance of this book object or not, we are saying B is an instance of book. So as we know, this B variable refers to an object called book. So which means when we are checking B is an instance of book, it is going to give me true. But this book is altogether a new object. It's altogether a new constructor that we have created. It's not a string. It's not a number. It's not an object. It's not a boolean. It's not coming through this object. It's coming from a different object that we have created. So when we say B instance of string, it is giving us false. Why? Because this object that we created, it does not belong to a string. It is not of type string. It is of type book, which we have created. So we are creating our custom constructor. We are creating a function which should set the properties values for book by this function invocation, and to invoke that we are saying new book. So whenever this calculation will happen, this variable will be referring to this book object, saying that this B variable belongs to this object. So whenever we say B is an instance of book, it's saying true. This is not a string. Whenever we are creating a normal string, whenever we say new string, that means we are creating an object of type string. So whenever we are doing that, or even if whenever we just make use of object literals, this is called your object literal creation that we always make use. Internally, JavaScript does this. So that is why when we said B is an instance of string, it gave us false. Why? Because this object does not belong to string now. It belongs to something called book, and we want this book constructor to set the properties of this object that we have just created. So this is how JavaScript processes every object that you are creating. To set the values of it, JavaScript makes use of something called constructors. Constructors are just like normal function, but to differentiate between a normal function and a constructor, we capitalize them, the first alphabet of them, and then to create an object of that particular create an object, we say new, and then we just call that method like this. So whenever we are saying new book, what we are exactly doing, we are calling this constructor to set some properties corresponding to the object that we have created. This object is then being collected into another object, which is my B, So that is why when we set B is an instance of book, it returns us true. Why? Because whatever this object is being, whenever we are creating this object, we are calling this constructor. That constructor may set some properties corresponding to the object, and then that object we are, just to make the accessibility easy, we are collecting it into a variable, we are collecting it into another object. In JavaScript, everything is an object. We are collecting it into another object, and we are just checking whether this object that we have created is of type this or not. So for that, we are making use of an instance of operator. Instance of operator checks whether one object belongs to another object or not. So for that, we simply said B instance of book, and it returns us true. Is this clear now? Are we clear about why we are creating constructors, or how to create a constructor? Mala, is this clear? Alright, now let's say whenever we are creating an object, obviously you have to set some properties with it, you need to define some let's say functions also within itself, some methods within it, within the constructor that we have created, so that we can provide more concrete object creation. So how exactly you can do that? How you are going to set some properties with the objects that you have created with the usage of your constructors, or how exactly you will be making use of this constructor pattern. So now let's say if I have to set some properties, let's say I want to set name and author. Okay, so now we want to create multiple books, as in we want to create multiple objects of the books that we have created. So to do that, what we did, we passed some parameters to this constructor that we just created, those parameters as name and author. Then to set these properties, to set these parameters that we have passed, we are making use of a keyword called this keyword. Have you guys discussed about this? So have you guys discussed it into your class previously? Okay. So obviously we are making use of this to set the properties that we have just defined, which is my name and author. So now whenever I have to access anything from this constructor, as again constructor is used to define some values corresponding to the object that we have created. So what we are doing now, we are simply saying that b.name and b.author, we want to print these values, and this is exactly how you can do that, how easily you can create multiple objects and you can assign values to them by the usage of the constructor. Your constructor will be used to define the values of the objects, or to define the properties of the objects that you have created, and then those properties can be accessed by your dot operator and by the objects that are referring to the objects that you are creating. So this is a variable which refers to this object and to access the properties of these objects. Now this is a custom constructor that we are creating. By default there are 8. We are creating our own constructor to create objects of type book, and then to access the properties that we are defining, all we are doing is passing them to our constructor and then accessing them by the variable, by the object that is referring to this object, and then by using dot operator we say b dot name, b dot author, and let's print them. So if you see, Harry Potter and Rowling is being printed. So this is exactly how you can create your custom constructor, and you can pass values to them by making use of this function. Now, this is one way of passing your or setting anything inside your constructor. Now if you want to provide more configurations, you can write methods over here as well. You can define some properties, or you can provide any type of methods within itself. This is one way of writing your methods into your using your constructor. Now let's say if I have to define some method, I'm defining a method called toString which will convert the parameters into a string. Let me write it first. Okay, so what we are doing within this function, we are writing a method which is a toString method which belongs to this particular constructor, this particular object that we have created. What we are doing inside this, we are just converting the parameters or properties into a string type, and we are returning it so that we can print them later on. So let's say now if I have to create this object, let's say this is one object that we have created. Let's say if I'm creating another object, and over here what I'm going to do, I will say b.toString just to print the string format, and b1.toString. So what we are doing, this object is being instantiated by the constructor. We are passing two properties, one is name, another is author name. Then we have a method inside this which is converting the name and the author property into a string type by attaching something within. Just as simple as that. We have created a toString method which will convert it into it. So now whenever I run this, every time an object is being created, it will have some method which gets attached to every object that you create. So every object will be having this toString method within itself. So let's say what exactly will be happening in my memory. This will be one constructor, this will be one object, this will be another object. This object now is containing the properties plus the method that we have created. So let's say whatever methods we have written, so over here is name, then author, and then over here is my toString method. So every object is going to be a combination of the properties that we are setting and the methods that we are putting inside it. And to instantiate that object, now we are making use of constructors that we are creating. So now your B is being represented by this and B1 is this. So this is how memory allocation is happening. B is referring to this object which is being created and B1 is referring to this object which is being created. Both of these objects are obviously, they are also object, but these are the objects of type this. These are the object of type book. Both of these objects are now type of type book. So this is how we are creating objects using our constructor pattern. We just have to assign the values to them. You can create properties inside them and make use of these properties. This is one way of creating your constructors and then assigning properties to them and calling those properties within your functions that you have written. This is one way of writing your functions within your classes. Now, is this clear? Is this way of creating or following your constructor pattern is clear? Right now we are writing our constructor pattern. Is this clear to everyone? All right. Now there is another very interesting thing that comes with your constructor pattern. That is another method called your object dot define property. With your constructor pattern, whenever you are creating an object, there is something called object dot define property. This method will allow you to set some properties corresponding to your object, but it will allow you to do all your necessary setup around your object. For example, whenever you are creating an object, it allows you to set some properties. It will allow you to configure your object in a different manner. It will allow you to provide some options along with the object that you have created. How exactly this method is going to be used? Now, let's say over here, this is as simple as that. I have just set some properties. I have just defined some values to it. Object.define property method allows us to create an object to set some property by the usage of something called getters and setters, by the usage of the object creation. How exactly object.define property is used? Let's say over here, this is my constructor. And let's say I'm passing name. Here. Let's say I want to create this object. I want to set the properties of this object by another method which is called your object.define property, which is just another way of setting some values inside your objects that you are creating. Define property, this particular method takes 3 parameters. Precisely, it takes 3 parameters. What those 3 parameters are? One, first parameter inside your object.define is the object that you want to create. So for example, the object that we are creating, what is the object that we are creating right now? This is the first parameter that this define property takes. Then let me write it. I'm just going to write a prototype first, just a template first, so that you can understand. Over here will be your key, and then comma value Okay. So this is how a standard object.define method, define property method is going to look like. The first parameter, it contains three parameters. First is the object that you want to set. Second is the key that you want to set, key as in the property that you want to set. And third is the value that you want to define. Now, with the third parameter, what you can do, you can attach some configurations with the object that you are creating. So what you can say, value would be the value that you are passing associated to the key that you have provided. Then there are three attributes that you can set. There are three other properties that you can set. First is your configurable. If you are saying configurable can have true or false values attached to it. Whenever you are saying configurable colon true, which means that you can configure this object. Whenever, let's say, if you want to delete it, if you want to update the object that you are providing, that will be allowed. If you are saying configurable equals to false, if you try to delete this method, sorry, if you try to delete the object that you are creating, that will not be allowed. By setting this configurable to false, you are saying that the object that you are going to create, that will not be deleted. If you set this property to true, which means you can operate on that object by the way you want. Then we have writable equals to true. If you see, this is just like writing a JSON. So we are providing the configurations over here. So what we are trying to say, first of all, this object is going to be writable is true, which means once you have provided these values, you can override them. If you have not provided, if you have set this writable to false, once you have provided a value, you cannot change that value again. So that becomes like a final variable that you have created. If you are setting writable to false, once you have assigned the value to the object, you cannot change the value. Then another is your enumerable colon true. Whenever you are setting enumerable to true, you are saying that this object key and the property should be available into your looping statement. Whether you are writing a for loop, whether you are writing a while loop, any type of looping statements that you are writing, once you have set this property to true, those properties, those keys that you are setting will be available as a part of those looping statement. So if you see what exactly this define property method is doing, we are doing the same thing. We are setting the properties, we can create object, but how exactly those properties are being set, you can configure that object. What you are saying, that this is my object, which means this object of my book, then what is the value? That can be name or that can be author, and then correspondingly the value we are configuring it. We are configuring it in the way that whatever value you want to set, you can set over here. Whether you want it to be configurable, as in whether you want it to be deletable or updatable, we are setting configurable attribute to true or configurable property to true. Writable true means that you can write it, you can alter the values of the object that you have created. Let's say if I am saying b.name, I am passing this by Harry Potter. Tomorrow I want to change it. Let's say I want to say b.name is equals to complete JavaScript. Something like this. If my writable is false, whenever I'm going to do this, I will get an error. It will not be allowed to me to write something inside this object once I have created it. To do this type of thing, I have to make this writable as true, which means this object is now writable. I can change the values. To make this object keys appear into your for loops, we are saying enumerable colon true. By default, all these properties are true. You can change these properties. So if required, you can set these properties. You cannot set this property. So by default, all these properties are true. If you want, you can change the values of this property any way you want. So this is how exactly your object.define property looks like. This is how you can make use of your object.define property to set some values. Now, if you find this a little difficult to understand or to write your object.define, what you can do, you can create a variable as well, just like creating a normal variable to set some value. So for example, let's say instead of doing this right now, I'm just writing a prototype, or as in syntax. Actual implementation I'm going to show you up next. Let's say if you don't want to write it right this way, you want it to be more understandable, what you can do, I can say var props is equals to function. This is my object, first is my object, then I'm saying key, then I'm saying value. Over here, let's say config is equals to value colon value, and let me just say configurable colon true. Any number of properties you can set, that's up to you, and this is what we are doing. And over here, now I can say object dot define property this comma, let's say I'm going to pass name comma config. Let me explain it to you first. Let me just take one key over here, name. Alright, so what we are doing, we are calling this method which is used to define some properties with the object. What is the object? Object is my this current object that I am writing, which is my book object. Then what is the property that I need to set, which is that name, which is the key that I want to set. How I want this property to be set, this is the value that I want to pass. How exactly that value should be configured, it should assign the value which is being passed, then it should be configurable, it should be writable, it should be enumerable. So not only I'm setting the value, I'm configuring the object the way I want. So this method, this define property method, so this is just an alternative way to write your define property. Either you do this or you do this. That's up to you how you want to write it. If you find this way easy, then you can do this way as well. So if you see over here, we are just setting up the values corresponding to what we are doing over here, but to make it more readable, we are getting that into a variable, and then we are configuring it just like a configuration of a JSON object. So if you find this way easy, you can make use of this one, or if you find this way easy, you can write your define property by saying something like this. So now whenever I have to create an object, I can create that object the way I want, any way possible that I want. For example, let's say whenever I will be doing this new book, I will be passing this name, and then that name will be going to set into my name variable, and then value will be set as Harry Potter. So this is exactly what is going to happen. The key is the name and the value that I am setting is Harry Potter. So this is exactly how you can set the properties using your object dot define property value. Whatever values you need to specify, whatever values you need to set, you can set them by using your define property. And define property allows you to configure your object the way you want or any way you want. That's exactly what you can do by using your define property. Now let's say if I have to do over here, let me run it first so that I can show it to you. B dot name. Let's run it. Oh, okay. Okay, one second. Before I do like this, let me tell you something else as well. Let's write one of the easiest way to use define property. Okay, so this is just a prototype. Now, how exactly what else you can do inside your object.define property? Let's say whenever I'm saying object.define property comes with two other parameters or two other things called your getters and setter. Inside your define properties, what you can do, you can access the properties that you have provided by usage of something called a getter function, and then there is something called a setter function. How exactly that object is going to, how exactly is it going to impact you? Let's say this comma name, this was a mistake that I made earlier, comma, let's say now let's set the values. Let me write it, then I'll explain you exactly what I'm doing. All right. Okay, so what we are trying to do over here, object.define property is used to set and configure the objects that you are creating. This is the object of my book. What property I want to set? I want to set name. How exactly I want to set it? I am using object.define method. Either I do it the normally how we were doing it, this dot name, this dot author, and then write methods, whatever, however I want to. Either I do that, but instead of doing that, I want to make use of this define property method. So what this define property method takes, it takes the object that you want to create, which is right now my book, then the key that you want to set. Let's say this is the key I want to set, which is my name key corresponding to the value that I'm going to pass. So this is the value that I'm passing. Let me say it as value. Okay, so this is the value I'm passing. The value I need to be set into a property called name. So this is going to be key. Then I have created two functions. One is my getter. This get method will be used to get the value of the property that I have set. Why? Because I'm again making use of this function, which will allow me to create objects more easily. I'm providing more and more options in order to access my objects property. I do not want them to be accessible directly, but instead I'm using getters and setters to set the values of the property. Then what I'm saying, this get function will return me the value that I have set corresponding to the property. This set function will set that property value. Okay, and then finally I'm setting these another properties, which is configurable, writable, and enumerable. You can, if you want, you can set few of them. If you want, you can set none of them, however you want. Now let's see what happens if I run it. Cannot both specify accessor and a value write table. Oh, okay, so if you see Harry Potter is now being printed, what we did, we have just created an object.define property which says that this is the object that we need to set. The key that we want to set is name. The values that we want to set are, the value is the one which I'm passing to the object when I'm creating it. This is the variable in which I'm accessing it. The key that I want to set is a key which is name. I can set it as any way. So what we are doing right now, we are making use of object.define method to configure the objects that we have just created, to configure the objects that we want by using object.define property method. And to access the properties, we are writing methods getters and setters. Getter is a method that is used to get the value of any object. So you can define your get method within your objects. All right, I'm sorry about that. Okay, so what we have just created. So this is another way of defining the properties inside using your constructor pattern. Either you just set them directly, but when we are saying object.define property, we are making sure that along with the normal configurations of our object, we can attach some other configurations with them. So that is why we are making use of object.define property method to define some properties along with the objects that we have created. Okay, is this clear? Is object.define property clear? Mala, is this clear to you? Okay, so now similarly right now I'm just setting, if you see, object.define property is allowing me to set one property at a given point of time. If I have to set multiple properties, just like I have set author and name, if I'm using object.define property, I may have to write multiple properties along with the objects that I have created. Okay, so now let's say if you have to set multiple properties. So for setting multiple properties, there is another method. That method is called your define properties. Instead of saying define property, you can say define properties, and then you can set the values corresponding to the multiple keys that you are creating. So this will be one key. After that key that you have just specified, again write comma and start writing values for another key that you want to set. So one key. So how you are going to write? Something like this. One key will be coming over here, then next key will be starting. Let's say over here I want to specify second, and then say colon, and set the values corresponding to it. So if you want to set multiple values or multiple keys within the object that you have created, you can say this type of notation. So this will be one key that we are setting, and then this can be another key that we want to set. So based upon that, you can set multiple keys within your objects by using your define properties. If you want to set only one property, you can say object.define property. If you want to set multiple properties, you can say define properties, and then similar type of configurations you can provide. You can say getter and setter, and over here you can pass two values now to set the values of two properties. So value would be, first would be, let's say, my name, second would be my author. Name value is going to be set by this name property, and the second one, author, would be set by, let's say, this author property that I am going to create. So over here I can say author. So whatever values I want to set, that will be set corresponding to the author that I have provided. So let's say over here, if I specify value 1, and so on. So now whenever I'm going to pass that object two variables, those values, those properties will be set corresponding to the values that I am passing, which I can again make use of, or which I can access based upon what I'm trying to do. So now author is also accessible. So if you want to define multiple properties, you can make use of your defined properties instead of saying defined properties. So now this pattern, this particular pattern that we have just written, this is called your constructor pattern. We are creating the objects by using the constructor of it. If you can just directly set the properties by this dot name or this dot author, define the variables that you have created, define the methods within, or you can make use of your object dot define property or define properties method. If you have to set any other method, let's say if I want to define toString as well, I can say toString. Any number of methods, just whatever you want to do, you can do those things using your method, using your object property as well. So these are two ways of defining your defining your objects using your constructor pattern. Getter and setter are two methods which are used to set some values and to get those values. To get the values, you simply say get and you return the value that you want to be returned. To set that value corresponding to what you are passing, we make use of a setter function. So these two functions, they are the standard function that people use to get a property, to get the value of a property and to set the value of a property. How you define them? You say get and then you just return the value that you want. Then to set that value, you pass something to the function and then you set that corresponding to what you are passing. So if you want, you can make use of these functions to get and set the properties. Why we are making use of these functions? So that we can make use of more of encapsulation. Encapsulation is one of the most used OOPS concept, which says encapsulating the data and the properties within the object and accessing them by those properties that you have provided. So what we are doing, rather than directly setting the, you can simply say this dot name is equals to that, this dot author is equals to that. That's also fine. That's something that you can again do instead of using getters and setter. But what I'm trying to do, that this is a better way of accessing the values of your properties by providing your getters and setters, because they allow you to encapsulate your data or encapsulate your properties in a more appropriate way. You are using more and more OOPS concept. You are structuring your code in a very, very better manner, and this is exactly what we are trying to do. Now, whenever we are creating the object, whenever we are creating multiple objects as well, every time when that object gets created, there is going to be a structure looking like this, which means every object that we create, it will have its own version of methods that you have created. For example, getters, for example, toString. Every object that you create, every object gets its own version of the functions that you are creating. They all create different, they all have access to different methods that you are creating. To make it more simpler, okay, before I go there, is it clear till now? Are we clear? Okay, now there is another thing that comes with your constructor pattern, that is your constructors with prototypes. What are constructor with prototypes? Most of the functions in JavaScript, they contain a prototype object. Do you know about what is a prototype object? Do you guys know what is a prototype object? Yes or no? Okay. Every object in your JavaScript, whether it is a function, whether it's a string type, or whether it is any normal object that we contain, it contains a prototype. Prototype will be, let's say, whenever you are creating an object, if you do not define anything with that, if you do not set any properties with it, if you do not want to set any corresponding value to it, it contains a default template attached to it. Template as in that whenever you do not have anything, whenever you are just creating a blank object as well, whenever you are not passing any values to it, creation of a blank object at any given point of time, if you do not set any value, there is going to always be a prototype which is going to be a default value or default thing that you are going to attach with that object. That is exactly what a prototype of any object that you have. Whenever you call a constructor to create an object, all the properties of the constructor are then made available to the prototype of the newly created object. So let's say whenever I'm just creating a new book, if I simply say new book, just like what we have been doing, we know that by default there is going to be a default prototype which will just create an object without assigning any values to it, just lying there an empty object. So that is your prototype of an object. But whenever we pass some values, whenever we create some properties, whenever we create the object, all those properties of the constructor's prototype are then made available to the object that you have created. So let's say by default JavaScript provides a prototype. Whenever you are done with that prototype, let's say whenever you are changing something in that constructor, the default values, whatever that prototype is holding, will now be attached to the object that you are creating. So for example, whenever I say new book, I'm creating an object. That object which is now being created is precisely coming from a prototype which JavaScript gives you. Whenever I do something like this, where b is equals to new book, which means the prototype, this prototype which is having which is available in the memory, is now being assigned to this object that we have created. So prototypes are nothing but just a blank template that JavaScript will always provide to you. No matter what you are doing, no matter how you are creating your object, a prototype will always be available for you to access it, for you to make use of the properties of your default constructor of the or the default objects that you are creating. Now what happens every time whenever you are creating a method, that method will have its own copy across the methods that you are creating. So whenever we create an object, we are saying that the prototype is being assigned to the objects that we are creating. If you want to omit this, if you want to say that, let's say I do not want every time a new method to be created, a new method to be assigned to the objects, especially when I'm creating similar type of objects, I want a prototype to be created. I want that prototype to be accessible throughout all the objects that I'm going to create. So for those type of thing, what you can say, when you are creating a method, instead of creating that method as normally, you can create that method as a prototype of the objects that you are creating, so that that prototype, as I just told you, prototype is available throughout your objects, throughout your for all the object. That's just something that you create for your that gets created by your JavaScript. So what your constructor prototype says, that instead of redefining your object, instead of redefining methods for your objects, what you should do, you should create your methods as a prototype, so that every object, rather than redefining the object, it can just access that prototype. So for that, what we have a keyword called prototype. So rather than doing this dot toString, what I can say, I can define prototype, this method as a prototype. So what we are trying to do, that this method now should not be redefined for every object. Every time a new object is being created, it's defining its method toString. But rather than doing this, create this method as a prototype, so that every object that you create, they will share a single instance of toString, which is going to be shared by multiple objects. Rather than every object having its own toString method, we are creating it as an object prototype. We are saying that when we have created it as an prototype, every object that we define or create will share this method rather than creating its own version. So this exactly what a constructor prototype is going to be. Every object that you create has its own prototype object, which then gets assigned to the objects that you create, and every object will have its own version of the things that an object is doing. So rather than doing that, what you can do, you can create an object by defining the prototype of it, and you can simply assign that prototype. So whenever now, if I'm going to do a toString, whenever I'm going to call this toString method, now that toString method will be shared across multiple objects rather than redefining it again and again. And this is what your prototype method is going to do. Every object will share a single instance of your toString method. So what we did, we just created a method by using the prototype of it, and this type of method is called or this type of approach is called your constructors with your prototype. So this is exactly what you are going to do. Whenever we say object dot create, if you remember in the beginning, I told you that there are multiple ways of creation of object. One way was object dot create. So if you see over here, I was passing this parameter which was object dot prototype. Every time an object gets created, there is a prototype which gets attached to it by default by JavaScript. If you want to make use of that prototype, rather than redefining your objects again and again, we can simply make use of this particular way of writing or this particular way of defining methods, which means we are creating something which makes it accessible across the objects, only one instance of the method that we have created by using the prototype of it. Is it clear? All right. Now, let's say if you were making use of this approach, if you remember, I defined something like this. Now, let's say if you are using this type of function creation where you are defining your property by this props variable that you have created. If you have to make use of this variable to create your objects, how can you do that? Let's say this is one way of creation of the object that you have just seen. Let's say if I want to create objects by using object.create, what I can say, b is equals to object.create object.prototype, and let's say I will say prop Okay, sorry, not here. Where is it? Here. Object.define property, then this is the end of it. Now let's say if I'm creating var new book is equals to, I will say object dot create object dot prototype. I'm just telling you another way of creating your objects. And then I can say props new book, comma, what am I passing here? Value. Let me just pass one value. New book, comma, value. And so on. So whatever value I'm passing over here, this is the object that I'm creating over here. I can just say this as well. So instead of doing this, I can simply say object dot create object dot prototype and then say this comma value. So this comma value, which means wherever I was defining this object dot define property like this, I'm just passing the values corresponding to it and I'm calling that inside. So whenever I'm going to instantiate, this is how exactly I can do that, to call anything from your object to creation. To allow the object creation, what you need to do, you will be saying object dot create, pass your object dot prototype, and then whatever value over here, call this function by the object that you have created, and then whatever value you are passing from the top to set the value. So this is another way of creation of the object using your object dot define property. If you are saying object dot define property, either you provide getters and setters, or you simply say object dot create to get started with this object dot define property method, and pass the object dot prototype, which will create the object as a prototype that you have just provided. Obviously this is, see, it's just a language. It's up to you how you enhance it, how you expand it. If you want, you can do the similar things in different manners. You do not have to make use of your constructor pattern. You can simply create variables and go about that. All these patterns that we are discussing, they will allow you to use different concepts of your JavaScript. We are creating objects, we are encapsulating them, we are not letting anybody access them outside the scope of the constructor. The properties are now being accessed by the getters and setters. We have a standard methods that are using to set or to do the calculations over the object. So that is why people make use of constructor pattern. You have done privatization of the properties and the methods. Everything will be accessible by the objects that you are creating. These objects are being set by the constructor which you have just created. To inside your constructor, you can simply set the values, or you can make use of your object dot define property method to set the values the way you want. So this is what a constructor pattern is. You can specify the prototype. When you are specifying the prototype, one instance of the method will be accessed by all the objects that you have created, and this is the usage of your constructor pattern, and this is how you define a constructor pattern. Are we clear? All right, next pattern that we have is a pattern called module pattern. Module pattern uses a notation, or uses another pattern which is a basic pattern called your object literal notations. Which is again a pattern, a very basic pattern that is used to organize the objects that we are creating, which in turn is being used by module pattern as well. So now what this Object literal pattern says it allows you to organize the code by the behaviors that an object is going to have. Behaviors as in by the methods that it is going to have. So what your object literal pattern says, that whenever you are creating an object by the literal definition, now we will not create an object by the constructor, we will just create an object by the literal definition of it. So if you remember, I was telling you about object literals, right? Do you guys remember object literals? Just saying this is called a creation of an object by literal of it. So what your object literal pattern says, that whatever variable you are creating, whatever object you are creating, in order to define some properties, in order to define some behavior to it, you can just do that within the object notation, within the object definition itself. How? Let's say if I'm creating this object, let me take it student. So inside this function itself, whatever behavior the student is going to have, provide that behavior within itself. Let's say register. So what this object literal pattern says, that rather than polluting your namespace, which means that rather than creating multiple function, if you would have done it normally, you would have created a function called function register, you would have created a function called function schedule, and so on. So what your object literal pattern says, that whatever features you have to provide, whatever configurations you have to provide, howsoever you want to structure your objects, whenever you are creating that object, at that point itself, provide the patterns, provide the way for you to access your objects by your object literal notation. Object literal notation says that an object can be described by comma separated name value pairs, which you are going to put inside your object definition. So instead of saying anything at all, instead of providing any other way of accessing your object, what we are doing, whatever values you have to specify, let's say over here I want to assign an ID. Let's say 101. Whatever values I want to assign, I can simply assign, or I can simply create them by using my object literal definition. All I have to do is provide a notation in which I'm just provide your notation corresponding at the time of creation of your object, provide everything inside of it, inside your object creation, and then just use those objects the way you want. Then if required, you can call those objects methods. So now if I have to access these methods, I can simply say student dot register. All the methods will be accessible by calling that object's name. So just like this, I can create my objects by using this pattern called object literal notation pattern, which simply says that any behavior, any property associated to the object that you have defined can be put inside the object at the time of object creation itself by using this object literal pattern, which means create a variable and then access it and then put the behaviors, put the properties within that behavior itself. So this is what your object literal pattern is all about. All you have to do is just create the object and then define the properties or define the behavior within itself, and then call those behaviors by the object literal notation itself. Just like if you have seen, whenever you have discussed about your string, if you remember, if you have understood your strings or arrays, different methods of your string dot concatenate, string dot anything that you have, all those objects are being accessed, all those behaviors are being accessed by your object literals itself. You just say the name of the string and then you call those functions. So this is what your object literal notation is all about. Create your objects by the literal definition and then associate the behaviors within themselves. Clear? So this is what your object literal pattern is. Object literal pattern is being used inside your module pattern. So that is why I told you beforehand, and how exactly we will see it tomorrow. We'll discuss in detail what your module pattern is going to be all about.